Let's now talk about the rules of sigma notation. Everything has rules. So to use the sigma notation, we can basically, let's look at when you add two different sequences, say sequence A and sequence B. Now, these two series, we can add them by first take A and find the sum of all the terms in A given the two boundaries, and then you're going to add the sum of the terms in sequence B. So if you are going to add two series, two different sequences that have their own sums, you can do that by finding the sum of the first sequence, the sum of the second sequence, and then adding it all up. And that's our first rule. Now, let's say instead of another sequence, you have a coefficient that is multiplying your your general formula. Maybe you have 4 into 3n. Now, if you have a general formula 4 into 3n, we can expand it in this way. You know that to expand, you will have, I really need to use two different colors so that it makes sense. You will have CA1 because our lower bound starts at 1, right? If our I is equal to 1, then that means we start from CA1, CA2, all the way until CAN, because n, our upper bound is n, just like you see it here. If it was 3, I would have went up until number 3. Now, you notice that with all these terms, term 1, term 2, term 3 in your series, we have a common factor here, which is C. Now, if I take out that common factor and I say, okay, let's put C outside, and then the terms that are inside, add them together. So if we take, we'll be left with term 1, term 2, all the way until term n. Now, you will notice that if we take out the common factor C, all the terms that are left inside here are just a sum of this general formula. So if we have 4 and we took out the 4 as a general, as a common factor, we'll be left with the sum of 3 to the power n, right? So let's just then give that its own sigma notation and say AI. This represented by sigma notation, we find the sum of all the terms of AI, and then we multiply that sum by some coefficient C. So if you have the sum of a general formula with a coefficient, you can just take out that coefficient to the outside and just find the sum of the terms to make it easier for you. Instead of having 4 times 3 to the power 1, 4 times 3 to the power 2, you can just take out 4 as a common term and then find 3 to 1, 3 to 2, 3 to 3, and then you find the sum of your sequence, you find your series, and then multiply it by some coefficient C. Now, with the rule number 3, I want you to focus on where the brackets are, because a lot of people make a mistake as to where the brackets are situated and what they cover. Now, in this first term, our bracket covers this entire 2n plus 1, which means 2n plus 1 is our general formula. These brackets attach this general formula to the sigma notation, right? So let's find from 1 up until 3, we will have 2 times 1 plus 1, that's 3. 2 times 2 plus 1, that's 5. 2 times 3 plus 1, that is 7. We only go up until 3, because remember, this is the lower bound and that is the upper bound. We started term 1 and added term 3. Now these values give you 15. Let's look at the second one. 2n plus 1. Now the 2n is in its own bracket, which means the 2n is the one that is attached to the sigma notation, right? So if we want to expand this, what we would do is put our brackets, find the sum of the terms into n. So 2 times 1, we started 1 and ended 3. 2 times 1 is 2. 2 times 2 is 4, plus 2 times 3 is 6. And then we add plus 1. Now this one, here we added 2n plus 1 and it gave us a term. Here we find the 2n in our series sequence and then we add 1 at the end. This one is not part of this general formula. So basically here we have this plus 1, this plus 1, and you can see that it gives us 13. It gives us 13 instead of 50, and they are not the same. So be careful as to where you put your brackets when you are working with sigma notation.